Hey guys, today we discuss about the minimum cost path problem of GFG. This is a stress problem. Yeah, this difficulty is hard. So let's try to understand the question. We have a grid of size n. Each cell of grid which contains an integer cost that represents a cost to travels through the cell. We need to find the path from top left cell to the bottom right cell by which total cost incurred is minimum. Find the cell ij. We can go like I comma j minus 1, I comma j plus 1, I minus 1 comma j, I plus 1 comma j. You can go in these cells. Actually we have to travel with these directions for itself. So let's see. Okay, this is our grid, and we have to travel so from top left, from here top left to bottom right to here. So we have to find the minimum cost. So we can go either this direction or this direction. So if you go to this direction, we get cost as 4 plus 4, 8, 8 plus 7, which is equal to 15. And if you go in this direction, 4 plus 3 7, 4 plus 3 7, and 7 plus 7, which is 14. So the answer for this question is 14. See, it is 14. Okay, so this is about the problem, and now we're going to discuss about the injection. How can we pull this? uh, we can actually use dp for this problem, but uh, here the directions, he gave the directions. We have to travel all these four directions, but dp process only works for two directions. We can either go from top to bottom or from bottom to top, so which is not possible in this case. So it's a graph algorithm. We have to solve it by using graph algorithm, Dijkstra's algorithm. So it is nothing but we have to start from the source state. So as this is the source, right? Yes, this is the source. It's to the destination state. So in the in what way? In the in what way the source has to be moved to every part of the cell, and we can only take the part of the cell which gives the minimum cost. Okay, so in Dijkstra's algorithm, the source has to move from every part of from this, from source position to the every part of the cell, and we considered only uh, the minimum path. Okay, for this but for this system, we have to build a dp, because we want to know, okay, what cell we actually covered, what cell we are not covered. So just uh, for knowing whether the cell is a traverser or not traverser, we use this dp. So this dp actually filled with maximum values. This m represents the maximum values. Why m? Because we have to give the minimum path. So we have to initially build the dp with the maximum path, and then when we compare, so we can we can put the minimum value in this dp. Okay, and what about this? This is a priority queue. As this stress algorithm definitely use the uh, priority queue in which uses min heap. Yes, priority queue is two types, one is min heap and max heap. So here we have to return the minimum uh, path. So for that we have to use the minimum priority queue. If I'm generally using priority queue, its syntax is very easy. Like priority queue, we have to give the data type and PQ. But in minimum priority queue, along with that, we have to tell okay on what comparator the in like coming coming values to this priority queue have to be compared. So we have to build the comparator for this also, and this IJK. So it represents I'm actually building a data type to put these values uh, into the into this priority queue. So actually we don't need a data type. We can directly put the values uh, for like fourth. As this is a source, so consider source the positions of source and its distance. First one, um, the I is 0 and the j is also 0, and the distance is equal to 4. The distance is equal to 4. So this first two represents the position. So instead of building a comparator, we can also uh, create a vector of vector or vector of pair. So this pair actually holds the comma j values, and then k, like int k, which represents the distance. Okay, so initially what we have done, so we can understand from code. So this is the code for this problem, which is this mean heap. Okay, uh, we have given the grid only. So from that grid, we have to find its coordinates, like how many rows are there. This gives the how many rows are there, and this is how many columns are there. And I created the mini heap as mini heap, and this mini heap can take the data type cell, and which is in vector form of cell, and its comparator. So the cell, this is my data type in order to store those values, the values which is nothing but the coordinates of the source initially, and then the distance to move from the coordinates of the source, which is initially a 4. For this initially the 9. Understand? So this actually takes the three integers, and whenever we created it, these are assigned the our given values are assigned actually to this data type with the help of this operator. This okay, which is nothing but a pointer which actually uh, point our value to the instance variable of this cell. Okay, consider this is a data type which I created in order to store the position and distance of the point. Okay, and this is the operator which is performed on it. So which runs actually uh, prefer to store the greatest value first and the lesser value second. Okay, after that, uh, so I created a DP. I told you already. So up to the size of n and m, we have to create it, and I created and filled it with, and I filled it with initial maximum